Welcome to the video lecture on programming in C. In this lecture, we are going to discuss the concept of arrays in C. To understand the concept of arrays, let us try to relate it to the construction of apartments with multiple flats. When many houses are needed for people to live, we either go for the construction of individual houses in a street or collection of flats in an apartment. The characteristics of apartments are very closely related to the characteristics of arrays. An apartment consists of many houses integrated into a single building. Usually all the flats in an apartment have the same design and size. The name of the apartment is common to all the flats in the apartment. Their postal address is also same. Though the name and postal address are same, a unique flat number is used to differentiate the flats. It usually starts with 1 and increments for each flat. So the last flat number is equivalent to the total number of flats in the apartment. Comparing to locating a house in a street, locating a flat in an apartment is easier. Using the flat number, we can sequentially search and reach the desired flat. Arrays are similar to apartments. Collection of related values can be combined into an array instead of declaring them as separate variables. An array can only contain values of the same data type, so we can't mix the values of different data types into an array. Like the flat number, an index number is used to differentiate the elements of an array. In C, the array index starts from 0. So if the array contains n elements, then the first element's index is 0 and the last element's index is n minus 1. The index is given in an incremental order. We can access the array elements by incrementing the index value by 1 until we reach the last element of the array. An array can be of any size, so the programmer must declare the size of the array during declaration. This is the syntax of array declaration. In this example, 3 arrays are declared. Just like the variable declaration, the data type is mentioned first, followed by the name of the array. Size of the array is mentioned within the square brackets. Remember, size must be an integer value. Let us look at an example to understand the accessing of array elements with the help of the index values. When we declare the array with the size as 9, the 9 consecutive memory locations are allocated for the array, which are collectively called numbers array. The memory addresses show that the memory is in consecutive order, but if we declare 9 separate variables, then their memory locations won't be in any order. But for arrays, the memory addresses are always in ascending order. To access the individual elements of the array, we can use their index values. Index 0 will point to the first element. Similarly, index 2 will point to the third element. So by changing the index values, we can access the different elements of the array. As I told earlier, arrays are an alternate for the declaration of separate variables that represents a particular type of value. In the first example, to represent 4 marks, we declared 4 variables with the different names. We take input for them and compute total by adding the 4 variables. Here we have rewritten the code by replacing the 4 variables by an array of size 4. So a single name is enough for all the 4 marks. Only the index values will vary for each mark. There is a better way to take input for an array, which we will discuss shortly. We will now see how to initialize an array when we declare it. Initializing is nothing but assigning values at the time of declaration. This is the syntax of array initialization. Note that the array size is not mentioned in the declaration. When we initialize the array, there is no need to declare the size. The number of values within the braces in the right side of the assignment statement will be automatically assumed to be the size of the array, so we don't need to mention the size. We can use array elements in any kind of expressions just like normal variables. In this statement, we add the value of a with the 5th element in the array. We can use array elements in conditional statements. We can take input for the array elements. But note that we can't print an entire array by mentioning the array name in the printf statement. So this will not print the array values. The only way we can print their values is by using their index values one by one. Even though we are able to access all the elements of the array using the same name, we are required to use multiple statements to access the elements of the array. For example, if the array size is 100, then 100 scanf statements are needed to take input for all the elements. It is tedious to type. To make it easier, we can combine loops with arrays. It is a standard practice to always use loops to manipulate the array elements, whether it is for taking input or for using their values in a formula or to display the array values using printf. Among the 3 loops we saw, for loops are naturally suitable for array manipulation. As we have seen, for loops should be preferred whenever we know the number of iterations that the loop needs to run in advance. For an array manipulation, the number of iterations are always equivalent to the size of the array, so we generally prefer for loops with arrays. The counter variable of the for loop is used as an index of the array. As it gets incremented during each iteration, we can traverse the array from the first element to the last element. Now we have used a for loop to take input for an array that contains 5 elements. This example demonstrates the accessing of the array elements by incrementing the index value with the help of a for loop. During the first iteration of the for loop, the value of I is 0, so the index of the array becomes 0. We take input for the 0th element. During the next iteration, I gets incremented to 1, and so the index of the array also changes to 1, and next iteration I becomes 2, and the index of the array also changes to take, and when I becomes 3, we take input for the 3rd element. During the last iteration of the for loop, we are able to take input for the last element of the array. When I further increments to 5, the condition of the for loop becomes false, so the loop stops. Just like this example, whenever we use arrays, we always associate them with the for loops that run for n times, where n is equal to the size of the array. Here I have modified the example of calculating the total of 4 marks using a loop. This code is shorter, free from mistakes, and easier to understand. This is the code for the sample problem that I referred in the previous video for locating a number in the list. The list is declared as an array and it is initialized with 9 numbers. So the size of the array is automatically taken as 9, which means we can use the index from 0 to 8. We ask the user to enter a number to be searched, and using the loop we start comparing with each element in the list with 7. We have used a break statement in this code. The break statement will end the loop abruptly without allowing it to run the remaining iterations. In this code, the break will be executed only when we find a match. For example, if the number being searched is 11, then during the 8th iteration, break will be triggered. By the time I will be 7. Now we need to decide whether we found the number or not based on the current value of I. So we use the value of I in the if condition. If I has reached 9, that means the loop ran fully and we could not locate the number. So the output will be number not found. But if the value of I is less than 9, that means the break was executed during some iteration and we found the number somewhere in the list. So the program will print the number found at the index with the value of I.